lengths compared to the corresponding side lengths in the original figure. And so what I said was, when the original image was copied at 75%, the lengths of the line segments are 3/4 the original size. When it's copied at 150, the line segments are 150% bigger. So let's say on my sheet, this line segment was exactly 1 inch, but it's probably different on the Promethean board. So that equals 1 inch. And then when I measured this, because 150% is twice as big as 75%, so 75 times 2 equals 150. So if you multiply the 1 inch times 2, you get 2 inches. And over here, on my paper, when I measured this, it was 2 inches as well.
So I'm speaking loudly, so hopefully it picks up on my phone. So what you're saying is that this side length here is twice this one here?
Is half.
Yeah. Half?
Mm-hmm.
Well, let's find out, shall we?
Yeah.
So I'm gonna make it a different color so it's easier to see. So we'll take it over here, all right? And then I'm going to duplicate it.
And yeah.
Is it exactly twice the length? Yeah. Okay, it is. Okay, so Cooper found that from this figure here to the from the smallest figure to the largest figure, the side lengths are twice as big. Yes. Do I have someone who can come up and show the connection between the original side length and the copied side length? Volunteers.
Jack.
All right, so can I have a pen? For the original side length,
The button that shuts the door.
for the original side length and the copied at 75%, the copied at 75% will be 3/4 the size of this line segment, this side length. And for copied at 150%, it will be, this side length will be 150% of that side length, or 3/2.
So can we prove that using Jack's line right here? Can we prove that using this line right here? So go ahead and prove that this line here is 70% the original. Go ahead and prove that using that line. Let's see a visual demonstration. If you're acting up as a problem, get your stuff out.
All right. All right. Then can I use a different line?
Of course you may.
Another way to say it would be this side length, this side length will be 1/4 the size bigger than this one. How do you duplicate it? How do you duplicate it?
So we have the extra 1/4 right there. All right, what about the angles? What about the angles? That's the next thing we need to look at. So what do you notice about the angles in this figure here versus the new figures?
The angles will be the exact same.
Can you move this triangle around and prove it to us, please?
So we'll start with the angle down here, and as you can see, it's the exact same angle and then the one up there is the same angle. And down there, it's the same angle.
Okay. What can we say about the perimeters? What can we say about the perimeters? What is the connection between the scale, the copier scale, and the perimeters? We have a volunteer on that one. Okay, Tess, come on. Jack, you did great. Thank you.
If the perimeter, do I have to say what that? I don't think we got the actual perimeters yet.
What is the connection between the scale?
Okay, so the perimeter of this triangle. Okay. The perimeter of this triangle is going to be. It's going to be, so if this is copied at 150%, it's going to be, you're going to multiply the perimeter of this triangle times 1.5 to find the perimeter of this triangle. And if this is copied at 75%, then you're going to multiply the perimeter of this triangle times 0.75 to find the perimeter of this triangle. Okay, it's not want to work. Okay, there. So that's going to be, if you're going to multiply the original times 0.75 to find the perimeter of this triangle.
All right, the last thing that we want to talk about really quickly is the connection between how many times larger the side lengths are and the area. So I'm going to go ahead, and it's a little bit easier for me to explain showing the connection between the smallest and the largest figure. So I'm going to copy this right here. All right, and so we've already established that to go from this figure to this figure, the side lengths were twice as big. So I'm going to take this figure here and fill it in here. And I'm going to duplicate it, and I'm again looking at the area. So right now I'm proving that this side length, this bottom side length, is twice as long as the small one. It's all right. You did a great job yesterday, Ryan. So how many of these original triangles fit into the large one? Well, when I have a scale factor of 2, in other words, the side lengths are 2 times as big, 4, that's right, 4 of these triangles will fit into this triangle. So that's sort of interesting. It's in this case, it's the scale factor squared, because the scale factor is 2, times bigger. The area is the scale factor squared times bigger. All right, finally, how do the copier code? Well, obviously, this is 150% of the original. This one is 75% of the original. And when we talk about this percentage, we're talking about the actual side lengths, not the area.